Hello friends, today we are going to solve GeeksforGeeks problem of the day of 13 June. The problem is stated we have given a number n and we need to count all the binary sequence of length 2n such that the sum of the first n bits is same as the sum of the last n bits. Okay, so let's understand the problem. We have given a length number n and we need to form a 2n binary sequence. Okay, and we need to count all the binary sequence that contains in which the sum of the first n bits is the same as the sum of the last n bits. Okay, so how can we do? The first approach comes into my mind, that is the binary to form all the sequence possible, and based on that we will count if the sum of the first n bit is the same as the sum of the last n bit. But this approach is going to exceed the time limit. Okay, so we can't do by printing or using the recursive way. So what we need to, how we can do it? We can do it by taking a mathematical approach. So what is the mathematical approach? The mathematical approach says that to in the first n bits to place k bits as 1. How can we assign k bits in the n length sequence? So we can do it. We need to count all the ways by which we can assign the numbers of 1 in the first half bk. Okay, so we can do it by n c k, which represent we need to choose k bits from n bits, and similarly we need to choose in the second half k bits so that the sum of the first one becomes the sum of the last one. Okay, so same for the second half n bits, we can place numbers of ones in the second half by nck, and total for a fixed k as for the binary sequence in the first n half sequence we need to choose k, and in the second half we also need to choose k bits in the second half. Okay, so total number of the ways becomes their multiplication. Okay, so here we are doing the same. The multiplication becomes the square of it, and so let me erase these all one. So here nck square. Okay, and as k value goes from 0 to n, why? As in the n bits we can place either 0 1, in the n bits we can place either 0 1, that there is no bit is 1. Okay, or we can place only one bit as a set, or 2 bit we can choose to assign it as 1, or 3 bits, or we can assign all the bits n, all n bits as 1. Okay, so thus the answer becomes summation of this one. Okay, and so and there is a theorem to find the solution of the sum of this one, that we can find this one answer by 2n cn. Okay, this value is the same as 2 2 2n in and cn. Okay, so we need to choose n bits from the 2n. Okay, so let's go into the second slide and let's understand by example. We need to find, so the answer of this problem is the 2n cn. Okay, so how can we find 2n cn? So let's understand. If we make a array in which we assign the factorial of each one from 0 1 to 2n. Okay, and the value of 2n and cn is given this one, 2n factorial upon n factorial into n factorial. Okay, but here is a tricky approach, that in modular arithmetic division is not allowed directly. We can't do like factorial of 2n, then divide factorial of n factorial, then also divide again n factorial. We can't do so. Why? Because modular arithmetic does not allow us to do it. So to do it, what we can do, we can use modular inverse. So here is given formula to find such solution. To do this, we can do this, means a upon b into mod of n. We can do it equal to a into b to the power minus 1 into mod of n, and we can do by Fermat theorem, b to the power minus 1 is same as b to the power m minus 2 upon mod m. Okay, so therefore the answer of this one, here we find the factorial of 2 into n, that's we find this one, and then we need to divide it by n factorial. So what can do, as we already learned that to divide and also we need to take mod, we can do it by this one, and this one is same as a into b mod minus 2, then again mod. Okay, so here we are doing the same. Here we find the factorial of 2 into n, then we are doing this one answer into power of factorial of n minus comma mod of minus 2. We are finding this one. Okay, after finding this one, we are taking the mod m. Okay, and after doing this operation, we again need to divide it by n factorial. So again we are doing this one, and at the last we are returning the our answer value. Okay, this is the solution, and let's go into the code panel. Yeah, here is the given function. We have created a factorial array of size 2 into n plus 1. Okay, and for factorial of 0 the value becomes 1, and for each loop we run the loop from 1 to 2 into n, and here we are assigning the value of factorial of 5. Okay, after assigning it, we need to find this one, and we are doing same. We are taking the factorial of 2n and dividing it by n factorial, and again dividing it by n factorial, and at the last we are returning the answer variable. Okay, so this function returns the value of b mod -2, and here is the function for that. Okay, so I think that I no need to explain the power function, as we are here finding the power of a to the power b. Okay, let's compile and run, and let's submit it. The answer is correct, and you can find this solution here. Go into the community section, and the problem is for the GeeksforGeeks, and you can check it here. And here I already updated the solution. You can find it and check it. So thank you for watching. Please like and subscribe.